If you prepare SolidWorks files for manufacturing, you probably know how much time export work can take. In this video, I will show how Solidise handles batch export automation. First, I am inside the Solidise browser workspace. These files have already been indexed locally from the workstation, so I can browse the project without opening every file in SolidWorks. As an example, I'm going to select this assembly with configuration -25 and some other parts. For this demonstration, I have also created a subfolder that contains an additional part file. When working across multiple folders, it can be easy to lose track of which files have already been selected. That is why Solidise includes the View Selected button, which lets me quickly review all marked files in one place before adding them to the automation queue. Solidise also indexes drawing files, but they are mainly used for reference. This makes it easy to see whether a part or assembly has an associated drawing. When exporting PDFs, you do not need to select the drawing file separately. You can simply select the part or assembly, and if a drawing is available, Solidise can use it to generate the PDF output. To make file selection faster, Solidise also supports range selection. You can select one checkbox, hold Shift, and then select another checkbox to mark everything in between. You can also click and drag across the list to select multiple files quickly. Once the file selection is complete, I can send the selected files to automation. This adds them to the automation queue, where I can review the selection, choose the required export formats, and start the batch export process. For this demonstration, I do not need the SAT file format. Instead, I want to export an IGES file. This can be changed easily in the settings by deselecting SAT and selecting IGES as one of the required export formats. After changing the export formats, remember to save the settings. Next, I can choose the required output format for each selected file. In this list, I do not currently have a sheet metal part, so the DXF flat pattern option is not available. I will quickly add a sheet metal part to the selection so we can include that output as well. Now that the sheet metal part has been added, I can select the DXF output format for that specific part. Let me quickly check the rest of the file formats to make sure everything looks correct. The export snapshot gives a quick overview of what will be exported. It shows how many items are included in the automation queue and how many output files will be created. If you do not need to see this information while working, you can simply minimize the window. If everything looks correct, I can start the automation and let Solidise begin controlling SolidWorks in the background. Here, it looks like we have encountered an error. This happens because there are two identical parts in the export queue, and they would create output files with the same name. If the automation continued, one file could overwrite the other. Solidise flags this before the automation starts, so we can fix the issue first and avoid creating incorrect or missing output files. After fixing the issue, I can start the automation again. Now the export queue is valid, and Solidise can continue with the batch export process. Here we can see SolidWorks opening each file one by one and exporting the required formats. Here we can see the output folder with all 32 generated files. Now ask yourself, how fast could you export 32 files manually? With Solidise, the repetitive export work becomes one controlled automation process. It saves time, reduces mistakes, and keeps the output consistent. Instead of opening, exporting, and saving each file one by one, you can let Solidise handle the batch and focus on more important engineering work.